Hello friends, welcome back to the session. In this video we will be looking at the exercise 6.2. Okay, so in the last video I have given you a beautiful summary of all the topics, all the small topics which we have learned in the last videos. Okay, so this is nothing but I have given the summary. Okay, so this is nothing but the distance between the point and line. Okay, so the distance between the point and line, if they have given the point and the line, then we can make use of these two formulas. Okay, so distance means what? It's the shortest distance is always a perpendicular distance. The next set of two formulas is for the distance between the line and line. Distance between line and line. Okay, line and line. So I have given you this summary in the last video, and at the end we have the distance between the two parallel lines. The third part we have seen is the distance between two parallel lines. Okay, so don't worry about the length of this formula. As I have already told you, once we get the questions, the way we are solving is totally different than these formulas. Okay, perfect. Now let's directly move on to the first question of the exercise 6.2. So what it says, first question, find the length of perpendicular, find the length of perpendicular from 2 comma minus 3 comma 1 and to the line. Okay, not on, to the line, it's x plus 1 by 2 equals to y minus 3 by 3 equals to z plus 1 upon minus 1. Okay, so we have to find out the length of perpendicular from this point to this line. Okay, so first we will invest a lot of time in the understanding this first question, because based on this concept we will be solving each and every question from this exercise. Okay, so see here, suppose this is the given line, so it's a line, and this is the point P in bracket 2 comma minus 3 comma 1 they have given. We have to find out this distance. Okay, suppose this is a point M we have, and this, of course, it is a shortest distance means what? It's always the length of perpendicular is always the shortest distance. So this is the line and this is the point. We have to find out this distance D. Now see here, a concept which we will be using in all the questions is like, can you get the direction ratios of this line? Direction ratios of the line. Okay, I will indicate that L of dr. So direction ratios of this line. Okay, so definitely this direction ratio of this line are given in this equation of line, which is nothing but 2 comma 3 comma minus 1. Okay, can you get the direction ratio of this PM? So direction ratios of the PM, so PM uske direction ratios. Okay, can you get the direction ratios of the PM? Yes, of course, you know the coordinate of point P, and if I get the coordinate of this point M, then I will be easily getting the direction ratios of the PM. Okay, we know that the direction ratios is nothing but x2 minus x1, y2 minus y minus z2 minus z1. Okay, so let's consider iske direction ratios are what it is. These are maybe x1, y1 and z1. Okay, so we will consider these are the coordinates of this point M, x1, y1, z1. So then what will be the direction ratios of the PM? PM direction ratios will be what it is, x1 minus 2, y1 minus plus 3 and z1 minus 1. This we have already studied in the vectors. Okay, so this is the 2-point form of the direction ratio. You know the direction ratios of this line, which is nothing but 2 comma 3 comma minus 1. Now tell me the note which we have already studied in the vector form. Whenever two vectors are perpendicular, then what is the relation between the direction ratios? Okay, that is nothing but the sum of multiplication of DRs is always equals to 0. Okay, sum of the multiplication of the DRs is always equals to 0 means what? 2 into x1 minus 2 plus 3 into y1 plus 3 plus minus 1 into z1 minus 1, it is equals to 0. Okay, so this is what we are using, the master concept, you can say. This concept we will be using in all the questions. Very important. 3 points we have considered here. We have considered this x1 y1 z1 as the coordinate of M. Okay, we have taken the direction ratios of PM, and we have taken the direction ratios of the line, and we know the concept, that is the perpendicular lines direction ratios multiplication is always equals to 0. Okay, this is the base for solving all the questions. Perfect. Now our task is to get the coordinate of this point M. Now can you tell me what is M point? M is the foot of perpendicular drawn from the P. Okay, and this M is also lying on this line L. Means what? The coordinate of this point M, x1 y1 z1, should satisfy this equation. Yes or no? Yes, perfect. Now let's see, we will substitute that coordinates. Okay, so x1 y1 z1, so what I will be getting? So for now what we are doing, for coordinate of point M we are solving here. As M is lying on the line, it should satisfy the equation of line. So let's substitute x1 plus 1 by 2 equals to y1 minus 3 by 3 equals to z1 plus 1 by minus 1. It is equals to lambda. Of course, it is equals to some constant lambda. Now let's find out the value of x1 y1 z1 from this equation then. So if I get the first equation, x1 plus 1 by 2 equals to lambda, then what will happen? x1 is equals to 2 lambda minus 1. Similarly, I will get y1 is equals to 3 lambda plus 3, and z1 is equals to minus lambda minus 1. So this is what the coordinate of point M I am getting. So it becomes 2 lambda minus 1, 2 lambda minus 1, comma 3 lambda plus 3, and comma minus lambda minus 1. This is what the coordinate of point M. Perfect. Now get the direction ratio of the PM. Get the direction ratio of PM, and the direction ratio of PM is what? It is nothing but the x2 minus x1 and y2 minus y1 and z2 minus z1. So x1 minus 2, y1 minus x1 minus 2, y1 plus 3, and z1 minus 1. Okay, so it is x1. What is x1 is? This is x1. So this becomes this 2 lambda minus 1 minus 2. ये हो गया मेरा first direction ratio. Second is what? 3 lambda plus 3. Next we have plus 3. Okay, y1 plus 3, and we have z1, which is nothing but the value minus lambda minus 1. z1 के साथ है minus 1. Okay, so it is minus 1. Okay, so what will happen here? 2 lambda minus 3, first direction ratio, it is 3 lambda plus 6, second direction ratio, and minus lambda minus 2 is the third direction ratio. Okay, so we get here the direction ratios of the line PM. Now what is what we do with this direction ratio? Make use of this star equation. Okay, this star equation, we know that the direction ratio multiplication and uska sum is always equals to 0. Okay, so what we'll write here, the direction ratios of line is कितना है? It is 2, 3, minus 1. It is 2, 3, minus 1. These are the direction ratio of line. We know that sum of multiplication of perpendicular lines, sum of multiplication of direction ratios of perpendicular lines is always equals to 0. Okay, so what we'll get now? So equation number 3. So from 2, 3 and star equation, what you will get? Okay, 2 into 2 lambda minus 3, 2 into 2 lambda minus 3, plus 3 into 3 lambda plus 6, and minus 1 into minus lambda minus 2 equals to 0. That's it. This is the master equation for this question. not only for this question, this concept will be requiring in each and every question. So let's solve for lambda. So you will be having 4 lambda minus 6 plus 9 lambda plus 18 plus lambda plus 2 equals to 0. Okay, let's take the all lambdas together. 4 plus 5, 4 plus 1 is 5, 5 plus 9 is 14 lambda. So it is minus 6 plus 2 minus 4, minus 4 plus 18 becomes plus 14, it is equals to 0, implies lambda is equals to what? It is minus 14 by 14, which is equals to minus 1. Okay, now we get the value of lambda, which is equals to minus 1. So if we substitute this lambda in this equation in the coordinate of m, then we will get the coordinate of m. Okay, so let me take that coordinate of m here in the downside, so that it will be easy for us. So let's copy this, copy, and let's paste it here. Okay, yes. Okay, now for this lambda equals to minus 1, let's find out the coordinate of m. Okay, so m becomes what? It is 2 lambda, means minus 2 minus 1, ये हो गया minus 3. Then we have minus 3 into minus 1 is minus 3 plus 3 is equals to 0, and it is minus lambda, so minus minus plus 1 minus 1, ये हो गया मेरा 0. Okay, so the coordinate of m becomes what? It is minus 3 comma 0 comma 0. Okay, so what we have to find out now? The distance. You know the point P and you know the point M. If you know the 2 points, okay, so let me write these coordinates here. So ये coordinates हो गए मेरे minus 3 comma 0 comma 0. So if you know the if you know these 2 coordinates, then we can easily find out the distance between these 2 points. Perfect. So what is the distance? Pm is equals to what? It is a root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So using distance formula, the Pm is equals to root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Okay, so which is equals to root of, what is x2? x2 is nothing but point P coordinates, so P is nothing but 2, so it is 2 minus 3, so it becomes plus 3 whole square, plus y2 is nothing but minus 3 minus 0 square plus 1 minus 0 whole square, so which is equals to root of, so it is 5 square is 25, so it is 9 square is, so 3 square is 9, so it is plus 9 plus this is 1 as it is, so it becomes root of 10 plus 25 becomes 35 units. Okay, so what is the length of perpendicular drawn from P to the line? Which is nothing but root of 35 units. Okay, so that's it all about this question. So just remember the 3 points. Okay, we have taken one general random point on the line L, which is M. We have considered its coordinates, and as this point M is lying on this line, it should satisfy. So from that we get the coordinate of M in terms of lambda, and the property which we have used is the perpendicular lines direction ratios multiplication is equals to 0. That's it. Only these 3 points are more than sufficient to solve these type of questions. Okay, so while watching this solution, you may find it is a bit confusing, but trust me, if you take pen and paper and if you note down sequentially what I am saying here, so it will be very very easy. I am investing this much time on this question because I know that this concept will be using throughout this exercise. Okay, perfect. So it's a request all of you, please go through all these step by step solution and write down in your own notebooks. Okay, good. Let's see the next question now. Next question. So question number 2. Find the coordinate of foot of perpendicular. Find the coordinate of the foot of perpendicular of the foot of perpendicular. So you may get the length of perpendicular, foot of perpendicular drawn from the point 2I minus j plus 5k to the line r bar is equals to 11I minus 2j minus 8k plus lambda into 10I minus 4j minus 11k full stop. Also find the length of perpendicular. Okay, perfect. See here again in this question we have to find out the foot of perpendicular coordinates and we have to find out the length of perpendicular. The same question as we have seen in the first question. Okay, so they have given one point whose position vector is given, which is a 2I minus j plus 5k. Okay, and we have given one line also. So we have to find out this length of perpendicular and find out the foot of perpendicular. So this is m is nothing but the foot of perpendicular. This is a perpendicular, so m becomes the foot of perpendicular. We have to find out the coordinate of this point m. Okay, now how to solve this type of question, because this question is totally given in the vector form, but the question which we have solved in the first question is the Cartesian form. Don't worry boss, I have already given you the trick while we were in the exercise 6.1, that how to convert the vector form into the Cartesian form as well as the vice versa, Cartesian to vector. Okay, so let's use that form, that trick, and let's get into this vector form to Cartesian form. Okay, so point P is given as what? It is 2 comma minus 1 comma 5. This is the coordinate of point P. Okay, and this is the equation of line. In this is my a bar and this is my lambda and this is my b bar. So b bar is always parallel to this vector and this is a bar is nothing but the point lying on the line. So equation of line becomes what? It is a x minus a bar k coefficients. Okay, so this is the point A, which is nothing but 11 minus 2 minus 8. Okay, so x minus 11 by direction ratio of this point B, which is 10, it is equals to y minus minus plus 2 divided by minus 4 and z minus minus plus 8 divided by minus 11. Okay, so if you have not understood this, I request you please go and check my first video of 6.1, exercise 6.1. Now see here, the totally we get the question in the Cartesian form. Okay, so this point P, now this question becomes your first question which we have just solved. So this is the point P and this is the equation of line. How you get the coordinate of point M? You know that the M is lying on the equation on the line, so it should satisfy this equation. So you will be getting x1 minus 11 divided by 10 equals to y1 plus 2 by 4 minus 4 equals to z plus 8 upon minus 11 is equals to lambda. Okay, now let's solve for this x1, y1, z1. So x1 becomes, it is 10 lambda plus 11, y1 becomes minus 4 lambda minus 2, and z1 becomes minus 11 lambda minus 8. So this becomes my coordinate of point M. So it is 10 lambda plus 11, it is minus 4 lambda minus 2, and we have minus 11 lambda minus 8. This is the coordinate of point M. Now let's find out this direction ratio of this PM. See, the direction ratio of PM and the direction ratio of this line, summation multiplication is equals to 0. Okay, so P point क्या हो गया? It is a 2 minus 5 minus 1 and 5. So the direction ratio of PM becomes, so P is, let's write down P here. Now get direction ratio of PM with P in bracket 2 comma minus 1 comma 5. Okay, now you know that the direction ratio is given by x2 minus x1. So PM के direction ratios क्या हो गए, x2 minus x1. So x2 is what it is, you can take anything. Okay, PM means x2 becomes this part becomes the x2. So it is x2 10 lambda plus 11 minus 2 comma minus 4 lambda minus 2 minus plus 1 comma minus 11 lambda minus 8 minus 5. Okay, which is equals to 10 lambda plus 9 comma minus 4 lambda minus 1 comma minus 11 lambda minus 13. This becomes the direction ratios of the line PM. Now use the concept, the summation of the direction ratio of sum of multiplication of DRs of perpendicular lines is equals to 0. Okay, with the direction ratio of the line क्या है, so these are the direction ratios of the line, 10 minus 4 and minus 11. Okay, so let's have those with the direction ratio of given line. Direction ratio of given line is what it is, direction ratio of given line is what it is, 10 minus 4 and minus 11. So it is 10 minus 4 and minus 11. Okay, now what happens, 10 into 10 lambda plus 9. Okay, first with first, then second dr with second dr. So it is minus 4 into minus 4 lambda minus 1. Then we have minus 11 into minus 11 lambda minus 13. It is equals to 0. Perfect. Now let's solve for lambda. So it is 100 lambda plus 90 minus plus 16 lambda minus plus 4 minus plus 121 lambda minus plus 13 into 11 is 143, which is equals to 0. Okay, solve for this 100 lambda, so plus 16 116 plus it is 121. Okay, so it is 100 16 and 121, which is 7, we have 3 and it is 2, so it is a 237. Okay, so root of 230, sorry, it's a 237 lambda plus, let's see what is 90 we are having. So 90 plus 4 is 94. So 94 ये हो गया अपना 7, 9 4 13 3 कैरी 12, so 237. Okay, so ये भी आ गया 237 equals to 0. Okay, perfect. So what is the value of lambda then? So lambda becomes, it is minus 237 upon 237, which is equals to minus 1. Perfect. That's great. Now what you will get then, if we have the value of lambda, then you will get the coordinate of the foot of perpendicular. Now if you substitute this lambda equals to minus 1 in this equation, you will be getting the value that is a coordinate of the point M. Okay, okay, chalo, let's take this M point there. Okay, let me copy this. Okay, let me paste this. Okay, now have the coordinate of M, so substitute minus 1, so it becomes minus 10 plus 11 comma minus plus 4 minus 2 comma minus plus 11 minus 8, which is equals to, so it is plus 1, it is 1 comma 4 minus 2 is 2 comma 11 minus 3 is nothing but 8. So, okay, so 1 comma 2 comma 3 are the coordinate of the point foot of perpendicular. Okay, क्या पूछा था क्वेश्चन में, यही पूछा था ना. So find the foot of perpendicular, find the coordinate of the foot of perpendicular. So the coordinate of foot of perpendicular becomes 1 comma 2 comma 3. Also they are asking for this length. So length, how you will find out this length? It is the distance formula, root of x2 minus x1 y2 minus 1 z2 minus z1. Okay, so the distance PM is equals to root of x2 minus x1. Okay, so let's take, so this is my M point, and what is P point we have? So P point is nothing but it is 2 minus 1 5. is 2 comma minus 1 comma 5. Okay, so let's take 1 minus 2 whole square plus 2 minus minus plus 1 whole square plus 3 minus 5 whole square, which is equals to root of minus 1 square is 1, 2 plus 1 is 3 square is 9, minus 2 square is plus 4. Okay, so this is nothing but root of 14 is the distance of the length of perpendicular, that is a distance of PM, that becomes my length of perpendicular in this case. Okay, perfect. Boss, this is very simple. Yes, I agree that this involves a lot of calculation, but the only concept we are using is that finding the coordinate of point M, finding the direction ratio of PM, multiplying with the line's direction ratio and equating to 0, solving for the lambda, finding the distance using the 2-point form. That's it. This is the only thing we are doing here in this exercise. Perfect. Okay, now let's see how we can use the same concept when we want to find out the distance between the two lines. Okay, chalo. So let's take the third question now. Third question, find the shortest distance between the lines. Find the shortest distance between the lines. So what are the lines equation given? R bar is equals to 4i minus j plus lambda into I plus 2j minus 3k, I plus 2j minus 3k, and the second line is R bar is equals to I minus j plus 2k plus mu into I plus 4j minus 5k. Okay, so these are the two lines they have given and we have to find out the shortest distance between them. Shortest distance means what? It's the length of perpendicular. Okay, perfect. So this question is given in the vector form. So our first task is to convert them into the Cartesian form. So let's consider this is the line L1 and this is the line L2. Okay, so L1 becomes what? It is what? This is the point A and this is the parallel B vector. Okay, and these are the direction ratios. This is the point A on the line L2 and this is the parallel vector B. Okay, so with that we can easily find out the Cartesian form. So it is x minus what? It is 4 upon its direction ratio is what? It is 1 equals to y minus minus 1. So my y minus minus plus 1 upon second direction ratio is 2 equals to z minus no k term, so it is equals to 0 upon third direction ratio, what is minus 3. So this is my L1. So what about L2? So L2 becomes x minus 1 upon first direction ratio is 1 equals to y minus minus plus 1 upon 4 second direction ratio equals to z minus 2 upon third direction ratio is minus 5. Okay, so these are the two these are the two equation of line in the form of Cartesian. Okay, now how to find out the shortest distance? See here, we will make use of this formula. What is the formula? Is that bada formula is. So this is the distance between the two lines. So let's find out. Let's make use of this formula. Okay, so for this you require this del. Okay, we will call this denominator as a del. So it is x2 minus x1, y2 minus y1, z2 minus z1, L1 m1 n1, L2 m2 n2. Okay, so let's have that formula here. Okay, so the distance between the two parallel lines is nothing but del divided by root of that bada part, which is a m1 n2 minus m2 n1 whole square and so on. That formula is there. Okay, so first let's solve for this del, which is nothing but x2 minus x1, y2 minus y1 and z2 minus z1, L1 m1 n1, L2 m2 and n2. Okay, let's substitute the values here. So you will be getting x2 minus x1 means what? This is the x2 part and this is the x1 part. Okay, so it is x2 is what? It is 1, or you can take x2 from these points also. So this is x2, this is x2, y2 and z2, and this is x1, y1, and this is the point z1 passing through these 2 points. Okay, so we have 1 minus 4 minus 3, 1 minus minus plus 1, and we have 2 minus 0. Okay, so it is 1 minus 4 is nothing but minus 3. Then you have minus 1 plus 1 becomes 0, and we have 2 minus 0 is nothing but 2. L1 M1 and N1 becomes what? L1, this is L1 M1 N1, so it is 1 2 and minus 3, and we have L2 M2 N2 is nothing but second direction, this is 2 1 4 and minus 5. Okay, solve this determinant. So this is equals to minus 3 into, so it's minus 10 minus minus plus 12 minus 0 into something is 0 plus 2 into bracket 4 minus 2. Okay, so this is equals to minus 3 into, we have 2 plus 2 into 2, which is equals to minus 6 plus 4, which is equals to minus 2. So this is what we are getting, the first numerator, which is nothing but the minus 2. Now let's find out the denominator part. So denominator is nothing but denominator of the formula, okay, which is nothing but root of, okay, m2 n1. See this one, this denominator is very huge, but don't worry, I will be giving you a small trick there. Okay, this is what the denominator is. Okay, L1 M2 minus M1 L2 and so on. Okay, whole square and so on. So for that purpose, what we will do, we will write on first. Okay, let me erase this. So for that we will write down the L1 M1 N1 and L2 M2 and N2. Okay, which is nothing but, what are the L1 and L1 M1 N1, which is 1 2 minus 3, which is 1 comma 2 comma minus 3, and next we have is 1 4 minus 5. It is 1 4 and minus 5. Okay, now let's find out first part, that is multiplication of these two. Okay, so L1 M2 and L2 M1. Okay, so find out the determinant of this 2 by 2 matrix. Okay, so this is nothing but 4 minus 2, which is equals to 2. So this becomes my first part. This is L1 M2 minus L2 M1. ये हो गया मेरा first part. Now find out the second part, determinant of, now find out these two. Okay, so this becomes what? It is minus 10 plus 12, which is nothing but 2, and now third time you want to find out the determinant of these two. Okay, so which is nothing but 1 minus 5 is minus 5, and plus 1 minus 3 is plus. Okay, so it is a plus 3, which is nothing but minus 2. So these are the three parts in your denominator. So the denominator becomes root of iska square 2 square plus iska square plus iska square, so minus 2 ka square, which is nothing but root of 4 plus 4 plus 4, which is nothing but charitrikam 12, which can be written as 2 root of 3. Okay, so finally what is the distance? Distance is nothing but del divided by denominator part, which is nothing but, how much was our del? This was minus 2, so it is minus 2 divided by 2 root 3, and of course we have this modulus value, as a distance cannot be negative, so we have to take its modulus value. So if I cancel out these two, so what I will be getting? It is 1 by root 3. So this is nothing but your answer. So 1 by root 3 units is the distance between these two lines. Perfect, that's very simple. Okay, see, we have not used any big formula there, we have just make use of the trick. Okay, this small trick, or you can say this is the some writing pattern we have. Okay, but at the initially when you are writing the solution, you have to specify this formula. In your board examination, you have to write down this formula. Okay, so this distance is equals to this determinant divided by the root of L1 M2 minus M2 L1 whole square and so on. Perfect. Okay, that's great. I hope you are understanding all these questions here. Again, I am requesting you, please note down all the questions, just do not look at these solutions. Okay, so what we'll do, we will solve one more question and we will stop here. Okay, last question we will take now, the question number 4. It is the same question as that of third question. Find the shortest distance between the lines x plus 1 by 7. Oh, that's great, they have given already in the Cartesian form. Y plus 1 by minus 6, which is equals to z plus 1 by 1, and x minus 3 by 1 equals to y minus 5 by minus 2, which is equals to z minus 7 by 1. Okay, so we have to find out the distance between these two lines. Okay, so what we know, so there is distance is equals to this del divided by, this should be distance. Okay, distance divided by this del divided by that denominator part, which is a very huge part. Okay, let me write once for you. So this del divided by root of, which is L1 M2 minus M1 L2 whole square plus L1 N2 minus N1 L2 whole square plus M1 N2 minus N1 M2 whole square. Okay, so this is what we have in the denominator. So this is my numerator and denominator. So first let's find out this del. Del is nothing but what? It's x2 minus x1, y2 minus y1, and z2 minus z1. We have L1, M1, N1, L2, M2 and N2. Okay, so this is my del, which is denominator. Okay, so this is nothing but a 3 minus plus 1. Okay, let me find out first x1, y1, z1. So what are the x1, y1, z1? x1 becomes यहाँ पे -1 है and यहाँ पे -1 है. These are my x1, y1, z1, and x2, y2, z2 will be what it is, 3, 5 and 7. Please make note that the standard formula. What is standard form is x minus x1 by a, y minus y1 by b, z minus z1 by c. Just comparing that with this equation, we will be getting the value of x1, y1, z1, x2, y2, z2. Okay, so x2 minus x1. So 3 minus plus 1 becomes 4, 5 plus 1 6, 7 plus 1 becomes 8. L1 is nothing but these are L1, M1 and 1. So it is a 7 minus 6 plus 1, and these are the second L2, M2 and 2. So it is 1 minus 2 and 1. Okay, so let's solve for this determinant, which is equals to 4 into minus 6 plus 2 minus 6 into 7 minus 1 plus 8 into minus 14 plus 6, which is equals to 4 into minus 4 minus 6 into plus 6 प्लस 8 इंटू ये 16 आणि ये हो गया है माइनस के 8. सो ये हो गया मेरा -16, ये हो गया मेरा -36 एंड ये हो गया -64, विच इज इक्वल्स टू, सो एडिशन ऑफ ऑल दिस 6 12 आणि 4 हे 16 6 कैरी 1. ओके, सो ये हो गया 10 एंड ये हो गया 11. सो विच इज नथिंग बट माइनस ऑफ 116. दिस इज माय न्यूमरेटर विच इज अ del. Okay, now let's solve for this denominator, which is nothing but the this root of. Okay, so for that what we have done previously, we have write down the 7 minus 6 1 as it is. 7 minus 6 1, 7 minus 6 1, first they are direction ratios, and second are what, it is 1 minus 2 and 1. Okay, now let's find out those three terms. So first, in the first case you will be solving these two this determinant. So it is -14 plus 6, so which is nothing but minus of 8. Next next we will be having the determinant of this, so which is nothing but minus 6 plus 2, which is nothing but minus 4, and next we will be having the determinant of these two, which is nothing but 7 into 1 is 7 minus 1, which is nothing but 6. Okay, so these are the three terms. So let's take the denominator, which is nothing but the square of first one, minus 8 square plus minus 4 square plus 6 square, which is nothing but root of 64 plus 4 square is 16 plus 6 square is 36. Okay, so this is nothing but the same there, so it will be equals to root of 116. Okay, so denominator and numerator we get. So what you will get the distance then? So the distance is equals to minus 116 divided by root of 116, so it is in the modulus one. So the answer is what? It is 116 units. That's perfect. Okay, so I hope you have understood this question also. Perfect. So again I am requesting you, please do not just look at these videos. You take pen and paper and you try to solve the questions with this video. Okay, then only you will get the concept. Perfect. Okay, so with this we will stop here. In the next video we will be finishing this exercise 6.2. Thank you.